Good afternoon, everyone in this room. It is good to be the part of this conference. First of all, this is a pre-recorded presentation. In case of technical issues, this recording will be played at this conference. My name is Yosua Nugroho. I come from BIAC Meteorological Station. I want to deliver my presentation about my research entitled Comparative and Analytical Study of the Sea Currents Data from High Frequency Radar and Acoustic Doppler Current Profiler in the Bali Strait. Before I start, I want to inform you that this paper is a part of the Bali Strait Wave and Current Survey Project hosted by Research and Development Center of BMKG or Puslitbang BMKG at Bali Strait, April 24th until May 3rd, 2019. For your information, recently the government of Indonesia through BMKG built some HF radar sites to support marine transportation safety and marine tourism interests. And the Banyuwangi HF radar is one of the first HF radar sites built in Indonesia. For your information also, the Banyuwangi HF radar is in the range of the Bali Strait observation for sea currents. And the system began operating effectively on November 1st, 2018. And it is relatively new, I think. So the data quality needs to be well examined. In this study, the HF radar sea surface currents measurement data in the Bali Strait will be compared with the observed ADCP's data. And these are some recent supporting research in the different places and time. As we can see, there are wide variation of correlation, error, parameter value. Generally, they are showing a good result, but the radial velocity and direction of sea surface currents have various statistical data and irregularities. These variations indicate that each research location has its own characteristic and dynamics. And we know that statistical data from previous research at different times and locations cannot be used as a basis for declaring the validity of the HF radar observation data at a particular location. Therefore, it is necessary to hold verification of the HF radar output data using ADCP in the Bali Strait to determine the characteristic of variation and validity from the results of the observational data. Now I want to specifically show you all the research domain. The research location is in the Bali Strait and the research time is from April 24th to May 3rd, 2019. Okay, this is the bigger map of the research location. You can see the red dots here are the HF radar sites. The dark blue dots are the ADCP deployments point. The light blue here is the range of the HF radar observational point. And we can see the purple dots are the closest effective grid from HF radar to the ADCP deployment points coordinates. And these are the research data and instrument. The red text are the data. The green text here are the measuring instruments. And the blue text here are the processing software. The method of this research is comparative with statistical approach. And okay, let's move to the result and discussion. Let me zoom in the tidal condition graph and explain it. The horizontal axis here is the observation time in UTC, and the vertical axis is the sea level in meters. H here is stated as high tides, and L here and here is stated as low tides. Both of these graphs have a similar synchronous patterns, showing two highest peaks and two lowest peaks in the similar time interval. The tide types of ADCP 1 and 2 is a mixed tide prevailing to semi-diurnal, which is experiencing two high tides and two low tides in one day with different heights and periods. Let's move in the variation in correlation value of HF radar and ADCP on radial velocity with the tidal condition recently. We can see this is the horizontal axis, shows the observed time in UTC, and the primary vertical axis here shows the correlation value of the radial velocity of the HF radar and the ADCP, and the secondary vertical axis here represents the mean sea level, which is describe the average tidal condition in the Bali Strait at both location point at the time of the observation. From this result, the HF radar and ADCP at both observation points tend to have radial velocity data that only well correlated with the average first and second tide periods. You can see the red boxes here. While in other periods, the correlation is not good enough. We move to the box plot. Let us see a box plot diagram of observation point 1. Both data appear to have a distribution that tends to be normal, with a distribution of almost the same value range. We can see here. And this indicated by the tide distribution and slight variation of the data. And the data value also tends to have similarities. And we can see then at the box plot of the observation point 2, in general, both data have a distribution that tends to be normal but has a different range of data values. The HF radar has a median value that is much different from the ADCP data. Even the HF radar median data is in the outlier value of the ADCP. HF radar also tends to have a wider range of values with a maximum value greater than ADCP observation. This shows that the radial velocity value of the HF radar tends to overestimate the ADCP. The difference in the range of radial velocity data values of the HF radar and ADCP at the observation point 2 can occur due to the limited amount of data and observation time. Okay, let's move to current rows at the observation point 1. On the HF radar diagram, the patterns of sea surface currents direction is varying and inconsistent. We can see the spreading patterns here. And on the ADCP's diagram, the pattern of sea surface currents tends to appear consistent in two opposing directions. At the observation point 2, the trend of HF radar is consistent, but in one direction only. And the ADCP tends to appear consistent in two opposites. It's just like the ADCP in the observation point 1. From the result obtained, it can be seen that the radial velocity patterns and the direction of sea surface currents of the HF radar at the observation point 1 are influenced by many factors, because we see the spreading of the patterns here, which is thought to be influenced mainly by surface wind. This is in accordance with the projected measurement of an observation of sea surface currents carried out by the HF radar system. And we can see at ADCP, the radial velocity and the direction pattern of ADCP are only influenced predominantly by tidal condition, in both location. This is in accordance with the observation method used by ADCP itself. The current layer condition, based on the ADCP recording data, it can be seen that from the surface to the depths of the sea, the current velocity is increasingly homogeneous. The lowest level of ADCP 1 and 2 are showing a homogeneous tighter range and slower radial velocity at a range of 0 until 50 cm per second. And the highest level of ADCP 1 and 2 are showing a heterogeneous wider range and faster radial velocity at a range of 0 until 150 cm per second. This indicates that there is a persistence of sea currents in the deepest layer compared to the sea level. Okay, and we move to conclusion. The tidal condition in the Bali Strait at the time of observation are mixed tide prevailing semi-diurnal. The sea current's radial velocity characteristics show good persistence in the lower layer than the upper layer, and the radial velocity data of the sea surface current of the HF radar and ADCP tends to only have the same and representative values at the average of the first high tide and second low tide periods, with the HF radar data tends to overestimate the ADCP. And HF radar and ADCP sea surface currents data are influenced by tidal condition. The causes of differences in the distribution patterns of radial velocity and direction of sea surface currents cannot be explained specifically and absolutely in this study. The addition of more ADCP instruments at several observation points in the Bali Strait is highly recommended for better representation and data density. A longer observation time is also suggested to obtain better climatological data for more representative results. Okay, these are my references from 4 books, 8 journal, and 1 online resource. These research were supported by Puslitbang and Pusmetmar BMKG, and we thank our colleagues from STMKG who provided insight and expertise that greatly assisted the research. And if you are interested with my research, please kindly contact me at my email, WhatsApp, or Telegram. Okay, thank you very much for your attention.